Welcome back, folks. This is a video on the math problems of chapter number 12. In this first question given to us, and first of all, this question is from page number 600, and this is a solved example which I'm taking. Just before I start solving this question, I just wanted to tell you there is a bit of a confusion. That's why I was hesitating from making these videos. So I'll tell you, this is used as a carbon ion. So what happens in reality is, if it is a positive charge, if a proton is moving, then what we consider that then to find the direction, we use the right hand rule. uh, so that's why I was hesitating from solving this question. But one more thing I want to tell you, we will keep on using the left hand rule. We're not going to use any of the right hand rule because that's going to confuse you guys. So in this question, I will change it as a negative charge. And in exam, if you are asked any question, that will be based on the negative charge, because in reality, the negative charge moves. There is no positive charge that moves. All right, so a carbon ion with the mass of 2.01 times 10 raised to power negative 26 kg, and see the positive charge of magnitude this much. I will call it as a negative charge here. Okay, enters the region with an external magnetic field of this much Tesla. Find the perpendicular speed at which the magnetic deflection force will balance the gravitational force, such that carbon ion will travel in a straight line. Now, to make it, because I've converted into the negative, so I need to convert this one into north also, if I'm not mistaken. Let me just quickly see. Yeah, this will become north, and this will be south pole. So this is north and this is south pole. That's how the question is going to look like. So we'll continue using the negative charge. So this this is moving through this external magnetic field. So if I use the left hand rule, and if I put my thumb in the direction of the flow of negative charge, and then fingers should point in the direction where the south is. So tip of fingers, if these are my fingers, they will point towards the south pole, and the thumb will point in the direction in which the magnetic the thumb will point in the direction in which the electron or the charge is flowing. uh, and yeah, then the palm will be upward. So palm will come out to be upward like this, and that is the magnetic force Fm. And gravity, obviously gravity is trying to pull it in the downward direction, so it's asking what speed it shall move through this external magnetic field so that it stays balanced. So for that, we will call it as F net is equal to Fm, which is acting in the upward direction. So I'll consider it as positive. Whoops. And then minus Fg. Let me just quickly check, is this video being recorded or not? Yes, this is being recorded. And now net force is 0 because it must stay on its path. So I will move this on the other side, so I'll call it as Fg equal to Fm. Now, if you look into your formula booklet, you are given the formula for this question, that is magnetic force formula, which is QVB. Now you can put a sine theta with this one also if you wanted to, because now with the sine theta, what will be the story? If the angle is not given to you, just simply put theta equal to 90 degree, and when the theta is 90 degree, this becomes 1. So QVB will become, that's how the formula gonna look like. Because all three, if you open up your left hand, and you will see the thumb and your fingers are at 90 degree, and your palm is also 90 degree to your thumb and fingers. So that's why we take the angle as 90 degree. If the angle is given to you, you will just put in that value of the angle. Now this is QVB, and the sine theta we will put as 90 degrees, so that will become 1. And this is Fg is equal to mg. And once I'm going to put in the values, mass value is equal to 2.01 times 10 raised to power negative 26. That is given to us in the question. And then multiply by g value 9.81, which is equal to 1.6 times 10 raised to power negative 19. You won't put the negative charge here. Negative and positive is just to find out the direction, which we figured out with the help of left hand rule. And the Tesla, the magnetic field is given to us, that is 6.32 times 10 raised to the power negative 5 Tesla. That's what's given to me in the question. uh, and yeah, this is what's given to me in the question. And now I will divide both sides by 1.6, whoopsie, 1.6 times 10 to the negative 19, and the 6.232 multiply by 10 to the negative 5. Please make sure you do this division carefully so that you don't make a calculation mistake. So 1.6 times 10 to the negative 19, that cancels here, and 6.32 times 10 to the negative 5. Again, if you're not comfortable in doing it in one step, do it by breaking down the steps one by one, and you're gonna get 1.95 times 10 raised to the power negative 2 meters per second. That's how you're gonna get the answer. Now, this is the formula for magnetic force you're going to use when you are given the charge, velocity, and v, or means when we are talking about magnetic field, charge, and velocity. These are the three things we are talking about. There is another formula for the magnetic force that is in form of current. That is ILB. 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 And I means current, and current which is equal to uh, Q upon T, and which becomes I. And here I will put the sine theta also. Say sine theta concept will remain the same. This formula, you can always derive this formula by using the previous formula also. This was QVB, and if I convert the velocity, if I break down the velocity, which is displacement upon time. So displacement can be written as length of the wire and upon time. So QVB, Q, which will be L upon T, and B, and then I will just move this on the charge below the charge. So Q divided by T, LB, and that's gonna become force is equal to ILB. So if you're given the current, I is given to your current is being asked, then you can use ILB sine theta. Sine theta will always stay there in the formula. Now again, one more time, if the angle is given to you, then you will use the sine theta. If the angle is not given to you, you won't use the sine theta. Now let's look into this question. A thin conducting wire of 0.75 meter long has a mass of this much. What is the minimum current? So current is being asked. So I will put this formula as, again, Fm equal to Fg, which is a negative. Fg always acts in the downward direction, plus Fm, magnetic force. I will use ILB. ILB. ILB sine theta. If the angle is not given to us, we will put it as 90 degree, minus mg. We want to make it float, so net force, F net I should write, not an F net here. F net is 0, and then this is going to go on the other side. Mg equal to ILB, and sine theta is equal to 90 degrees, so sine theta is 1. So I value we are looking for, and length of the wire is 0.75, and multiply by 0.15 Tesla. Mass is 0.060 kg, multiply by G value is 9.81. Always please make sure you don't start putting a negative here, because we've already accommodated the negative sign here. So once you're going to solve this, current value will come out to be 5.2 ampere. Unit of current is always ampere. Ampere is the unit, written like this. So hopefully you understand how to solve these questions. And yeah, that's about it. So try and do questions mainly from 605 and 603. I I'm hesitant of doing page 600 because the reason being, as I told you, it talks about the positive and negative. So if you want to solve those questions, make sure when if a positive is given, you'll change the left to the right hand rule if a positive charge is moving through the external electric field. So that's it for this one. And yeah, I apologize I didn't make this video uh, earlier, and I wish you all the best for your midterm.